Good morning, everyone. Firstly, I'd like to thank everyone for dragging themselves out of bed to catch the 8:15 session. I know they can be a little bit harsh sometimes. I might actually give 1 minute or two more because there were still people coming in from breakfast. Don't want to wait too long though because I do have a fair bit of content to go through, so I do want to get started soon. I'll take the opportunity to say I do have a fairly full session planned. I'm happy to take questions through the presentation, but I've got what I think is a pretty cool demo to show everyone towards the end. So the more time I spend answering questions during the session means the less time there is for the demo at the end. Unfortunately, it's not the last session of the day, so we can't stay as long as we like. I'm also happy to hang around after the presentation, just off to the side, and answer any questions that people may have. Okay, I'll just go through the the introductions while people are still filing in before we start getting into the content. My name's Gareth James. I'm a senior consultant with Microsoft Consulting Services. And what that means for you, I guess, is that as a consultant, I'm the guy who spends all my time on customer sites actually implementing technology and making it work. And I'm one of the guys who sees when the technology works, and I'm the guy who sees when it doesn't work. I'm the guy that sees when our technology is implemented well, and I'm also the guy who sees when the technology is implemented very poorly. So you'll get a pretty frank and honest assessment from me where things work and where things don't work. I'm not a marketing guy, as will become apparently obvious very quickly from the quality of my slide deck. And I'm not a sales guy either. So, I'm all about making the technology work, but also about being realistic about what you can and can't do with it, and where its limitations are. And as you see when I go into the content of the session, it's not also just about the technology. To a very large degree, it's about the organisation, where they are with their maturity. And quite often we see that when organisations aren't being as agile as they'd like, it's not the technology that's holding them back. It's usually their internal politics or their process or their maturity levels that really hold them back. So today is all about private cloud best practices. So really, the first thing I want to do is define private cloud, because it's been in there for a little bit of time now, but I do want to take some time to define it, because cloud is a term that it seems every marketing organisation in every IT company has just latched onto as something that we have to say we're doing something with cloud, otherwise we're being left behind. But what I want to tell you is that from Microsoft's definition, cloud does really mean very particular things, and there are definitions in place, and if certain qualities aren't being met, then you can't really call it a cloud. Then I'll go into some principles. Then again, we really are talking specifically about private cloud here. A lot of the tenets of cloud are common to both public and private, but then we're going to drill down into private and what that means, and what two very specific viewpoints of private cloud are. Then we're going to talk about dynamic data center and where that relates when we talk about private cloud. And then the solution that I'm going to show you today is really focused on one of the pillars of cloud, which is infrastructure as a service. But I'll also explain how we can also then start to go deeper. And then I'm going to give you a demonstration of a solution that Microsoft Services have put together called Data Center Services. Now, I'm going to put out a huge disclaimer right now. My demo is about as high risk as it gets. I'm remoting back live into a shared lab in Redmond. So it might be a little bit choppy because I'm going all the way back to the States, but also it is a shared lab where people do live testing and development. So someone could have been in that lab half an hour beforehand and broken everything. I don't know. So we'll see how it goes. If stuff fails, then you know why. But I did want to show it because I think it's important to have a look at what's possible with the stack. And even though the demo is pretty high risk, it was either the choice of not showing it at all or taking the risk. And I think most people in this room would appreciate the fact that I want to take the risk and show it. So NIST, which is the National Institute of Standards and Technology, which is a US body, has a cloud definition framework. Now, to an Australian audience, might sort of think, well, okay, an American governing body, okay, why not an Australian one? I mean, obviously, Microsoft is a US company. The NSIT came out with their definition around cloud first. It was a good definition. We felt that we needed to align ourselves with a definition. This was a general public one that was fairly common sense and, made good sense. So we decided to align ourselves to that. So they define some common characteristics, some essential characteristics, and some service models when we're talking about cloud. And again, this is general, so it applies to both public and private. So I'm not going to read through the list because, I'm working on I think, a fairly safe assumption that everybody in this room can read. That normally gets a laugh. Anyway, there are some points there are some things I want to point out, and that is these are common characteristics. And note that they're not essential characteristics, which means that these characteristics are often found, or quite commonly found, in cloud solutions, but they're not essential. And so something like massive scale, for example, okay, that usually defines a lot of cloud-based services like Azure or LiveMail or whatever, Xbox Live or what happens to be. Quite massive scale defines these services, but if you're talking about private cloud in an enterprise, it's not on that scale. So it's not an essential characteristic. Another one that's very interesting is, as not being an essential characteristic, is virtualization. And I really want to call this out early and make sure everyone sort of understands where we're coming from here. There's a theme that has gone through a lot of, you may have seen it in the keynote or you may have seen it in some of the other general sessions, where we say virtualization by itself does not equal cloud, and cloud does not equal virtualization. And I think some people have taken that to mean, or interpreted it to mean, that we think, that virtualization is bad, which is, not the case at all. We take a very pragmatic and practical approach to these things, where we say, in a lot of use cases, and in fact we think probably in the majority of use cases, virtualization is an absolutely critical underpinning technology to deliver a lot of the tenets of cloud. But it's not essential. And there are some cases where it's very practical and in fact very, very cost effective not to virtualize. Some really high profile examples. Facebook, right? Pretty big cloud-based service. They don't virtualize any of their servers. And have been quite public in stating that. Office 365, for example, which delivers Microsoft Exchange on quite large, certainly a lot larger than most single enterprises, at very large scale. None of those Exchange servers are virtualized because it makes good economic sense with the way that those systems run not to virtualize them. So virtualization, very important, used in most cases, but it's got to be taken with a common sense approach of where it's practical to use and where it's not. Essential characteristics. Now, these are the things that we looked at within the definition framework and said, okay, these are must-haves. If you're not meeting any of these requirements, then you can't call what you're delivering a cloud. So, on-demand service, and that usually takes the place of some kind of self-service portal where, really the idea is a person hits a interface of some kind, be it a web portal or whatever it is, requests a service, and then they have the service spat out the other end with minimal hands-on or no hands-on involvement in that process. Broad network access, which basically means you can get to the service from wherever you need to get to it from. Resource pooling, so you're making good use of the available hardware. And again, virtualization is an excellent way of doing that resource pooling, but in certain circumstances, it's not the only way. Rapid elasticity, the service being able to scale up and scale down on demand. Now, that could be a manually triggered request, so the user could say, I need more servers in this environment, I want to scale out and request that. Or it could be automatically triggered from a monitoring system that says, well, this system's under pressure, I need to scale that service out. And then the last essential characteristic is a measured service. So that really relates to chargeback and reporting, the ability to know in a multi-tenant environment what each tenant's relative resource consumption is, so that they can both know how much resources they're consuming. The Fabric administrator knows how many resources they're consuming within the entirety of the Fabric, and then there could potentially be some kind of charge, although not in all cases, based on that information. And that's a I'll go into some of the challenges that we face with these systems, but you'll see that type of metering and quota is a really important part to how you actually have a manageable private cloud that is sustainable over time. The NSIT also define some service models. And if you've been to any of our other presentations that have anything to do with cloud, I'm sure that you've seen these definitions ad nauseum. So infrastructure as a service, platform as a service, and software as a service. Again, this was NIST definition stuff, so we didn't make up these terms. These are the terms that we thought, yep, that really makes a lot of sense, and we'll run with those. So what we're talking about in terms of the private cloud solution that we've defined is infrastructure as a service, so that's where we'll be focusing our attention today. Again, I'm not going to read through all of these, but the principles of private cloud, and these are some of the things that we need to think about when we're thinking about private cloud systems. I'll call out a couple of them and speak to them specifically, and some I'll actually go to in a lot more detail because I think for this audience they're fairly interesting and fairly topical. The perception of infinite capacity. Now, we all know that infinite capacity really isn't possible. There's a finite set of kit that you have, particularly when you're talking about private cloud, so that's most likely going to be in your own data center. You have the equipment that you have. It's not, it's not an infinite resource. But what you want to try and supply to your service consumers is the perception that there's always resources there when they need it. So when they make requests, that requests get service, and we achieve that through good capacity management and also through trying to incent good consumer behaviour as well, and I'll go into that. Another point is being able to drive predictability. These private cloud systems really, at their heart and soul, have a lot of automation and orchestration behind them. They need to. There's a lot of things that have to happen between A and B. Remember when I said they click a button on one end and they get a service spat out the other? Well, there's a lot of work that needs to go in the middle there. And I mean, traditionally, that's been a very process-driven process where you'll get the request. It may go to the storage guy initially, and then it'll go to the network guy, and then it'll go to the server guy, and then and it steps through all of these things. And we need a lot of automation and orchestration to really automate and orchestrate across those silos in order to have what is, from the consumer's point of view, a very, very simple service. Of course, every admin knows the amount of complexity that is at the back end to make that service a reality. Resiliency over redundancy mindset. Now, I won't touch on it now because I've got a whole slide on it. I want to drill into that in detail because that's a really interesting one. Minimization of human involvement. Again, that goes back to all of these processes that have to be gone through in order to provide that service, and how do we get as many hands out of that process as possible, make it as consistent and as repeatable as possible. That's key from both a consistency of service point of view, but it's also how these sort of dynamic systems fit into a change control framework as well. Well, in a matter of minutes, want to.
Someone might have changed the frequency somewhere.
Yeah, no worries.
You can do that on the install pack.
Oh, just did that before I put down my shirt. Great, thanks. Oh, that's better. So, who didn't hear everything that I said for the last 5 minutes? Okay. Where was I? Okay. Optimize of resource usage. I mean, that's to go into that should be pretty much a no-brainer. Incentivize desired behaviour. That's an important one from the point of view that it's great to have this perception of infinite capacity. There's a bit of feedback there. Perception of infinite capacity when we don't have it. And we've all, I guess, anyone who's had anything to do with server deployment and virtualization know only too well that when you make it very, very easy to deploy a server, that all of a sudden they start popping up everywhere and there's absolute VM sprawl. So if you want to run this thing as a tight service, you want to try and motivate your consumers to behave in a way that is conducive with the capacity that you have. Resiliency over redundancy. I want to spend a little bit of time on this slide because I think it really is one of the more interesting, for me, tenets of where we're going with cloud services and how that applies as well to private cloud. For the longest time, we've really had what we call a redundancy mindset. And a great example of that is when you look at how something like, say, SQL Server works in terms of failover clustering. It's a very doubling up of infrastructure in order to try and avoid a failure. Obviously, if a component fails, then you're relying on the fact that there's some kind of redundant path which is going to take over, and so therefore avoid failure of the server, and by so doing, avoiding failure of the service. That's a very expensive way of trying to ensure service continuity. And when we start talking about the scales that we see in some of the cloud services and in public cloud, that model just gets too expensive, frankly, to maintain. It's just not economically viable. So we're really pushing towards a more resilient model where we say, and I think a really, really good example architecturally is if you look at Exchange 2010 and how it uses local storage and uses DAGs to replicate data across multiple areas. And the idea there is we know failures are going to occur, right? Servers are physical things, disks are physical things. They have, in most cases, moving parts. You know, things fail, and that's just a simple reality of life. You know, the day that a server vendor, you know, can build a server where they guarantee 100% uptime is you know, the day I retire. It's not going to happen anytime soon. So we know failures are going to happen. The question is how you deal with them. And the way we've dealt with them previously is to have very expensive redundancy to try and keep the server up to ensure service. Now we have the server spread out through a web of servers so that when servers go down, it doesn't matter. There's enough resiliency in the architected in the service in order to deal with that. And again, another great example of that, which we've had for the longest time, is Active Directory. In a good distributed Active Directory environment, if a domain controller goes down, it's not really you know, in terms of impact to service, it's not really a huge tragedy. You obviously want to get the thing back up, but you know, it's not like no user can log on until you do. So, but this really sits at the app layer in terms of the application really has to be architected to deal with this resiliency model. And you know, I'll be the first to put up a hand and say, yeah, certainly not all of our services are currently architected that way, but it is definitely the direction in which we're heading. So now when we start looking at private cloud, we have two viewpoints. The viewpoint of the service provider and the viewpoint of the service consumer. Now, obviously when you look at that, you sort of go, well, you're duh. Yeah, you know, the person who's providing the service and the person who's using the service, it's pretty obvious. But it's important, there are really some mindsets here that we really need to start thinking pretty seriously about if we want to run a successful cloud infrastructure. There are some real changes in thinking that we need to that need to be in the organisation for these sort of systems to really be successful long term. So I've gone through a fair bit of the stuff in terms of service provider, sort of optimised research, usage, large-scale standardisation, been through that. The good one is classification of service, and you'll quite often see that in a lot of cloud systems. I mean, the popular one is, you know, the bronze, silver and gold. You know, which level of service do you want? And that's really important from an economy's point of view, because there is sometimes the mindset that one architecture is automatically and always cheaper. I challenge that assumption every time. You've really got to look at the detail of where the money's going, and I really will argue with anyone that one architecture is automatically cheaper. And you're seeing that in the levels of service in a lot of cloud infrastructures, right? So you may have your bronze service, say, going to much cheaper low-end storage, and your gold service going to really, really expensive high-end storage. Do you want to supply absolutely all of your service on really, really expensive high-end storage so you have one architecture? No, it's just too damned expensive. So you've got to take a pragmatic approach to how many of these do you need. And obviously we don't want 1 million architectures, because that's silly and that's what we've been doing for ages, and that's also really expensive. But you've got to bring it down. There is a tipping point where number of architectures, there's a tipping point where it makes the most economic sense, and could vary slightly from organisation to organisation. People and process aligned. Now that's really critical to the success of a good private cloud system. So I'm going to touch on that in more detail a bit later on. Now again, the viewpoint of the service consumer. Again, we've gone through a lot of this. What we haven't touched on is the utility style pricing, and that does go back to the chargeback model. It's the analogy of, I go and turn on my light switch, I get light, I pay for that energy that I use, I turn it off, it turns off, and I don't pay for that service anymore. So it's that service consumption utility pricing model. And well-defined and consistent quality of service. In order to provide a private cloud to our consumer, the service provider needs a dynamic data center, Microsoft, what we define as a dynamic data center. Now, Microsoft have been on this journey for a while. We've had our Dynamic Compute initiative going for some time, well before this whole big cloud focus happened. So we've understood the nature and the benefits of that dynamic computing for a while. So what we've got is Dynamic Data Center at the back end, which provides most of the qualities that you need for private cloud, and then you stick your chargeback and self-service and those little bits of frosting on the top that makes the Dynamic Data Center cake a cloud, if you like. Lots of principles there. I won't read through them. We've got the ones that I really wanted to call out. Fabric management is an important one. You've got this fabric of dynamic and pooled resources that people request service out of. You've really got to be able to manage that effectively. And it's one thing to just say manage it effectively. Oh, and can I sell you some software? It's not about that. It's about how you manage it in terms of process, and that's really critical. I'll go into that in a little bit more detail when I show you how we've built our solution, but I'm really sorry to tell you that if a vendor ever tells you that you can chuck some software in a server, say next, finish, and you're going to have a private cloud at the end, I'm sorry, you are on your way to a hiding, because you need the process at the back end to back these things up. You need your organization to be in the mindset of working in this way, otherwise the system simply will not be able to function because the organization will not have the agility to allow it to work. We've talked about virtualized infrastructure, service classification. Acute resource decay, that is an interesting one as well. And that really goes back to that resiliency versus redundancy mindset that I was talking about before. I'm going to tell you a couple of little anecdotes about how we do things in some of our data centers. Now, I don't want everyone running away from this going, oh, and the Microsoft guy said that this is how we're going to do it. A lot of what I'm will tell you now, it's an interesting anecdote to look at because people go, oh, that's how you do it. Well, that's interesting. The economies of the way we do things work for us at absolutely epic scales. Now, in most enterprise data centers, you're not going to hit anywhere close to those scales. So some of the techniques that we use may not necessarily, the economies may not work out for you because the scales are smaller. And when I say epic scale, at one stage when we were releasing some new web services, we were rolling out 10,000 servers a month. Anyone got 10,000 servers in their data center total? Didn't think so. So yeah, 10,000 servers a month. Think about that scale. The logistics of managing a data center at that scale. So we have to do things a little bit differently. When we talk about compute decay, what we mean is the sending people out to go and replace dead disks in servers and going out and servicing servers and having very expensive support contracts with server vendors so that someone can come out and change a motherboard in 4 hours. That simply doesn't work when you're rolling out 10,000 servers a month. It just does not work at that scale. So what we do in our data centers is we've gone to full Gen 4 now, so that means that we don't have server rooms anymore. We have effectively shipping containers or crates, or called pods, which have usually about 2,000 servers in them. They roll up on the back of a truck. We plug them into power and network, build our services into them. Well, that's all automated. So I think my mic just cut out, didn't it? No. Those services are automated. Those pods are sealed. We never open them, ever. We know what our mean failure rate on average is within those things. We've done a lot of work with Microsoft Research. We've done really good mathematical modelling on mean failure rates and that type of thing. So we've got a pretty good idea of what the failure rate within one of those pods is going to be over its lifetime. When disks fail, when servers fail, we don't care. We just leave them in the rack. Because the service has enough resiliency to survive those failures, and it's cheaper for us to leave those things dead in the rack, and then when that pod reaches the end of its life cycle, we chuck it out and we roll a new one in. That's cheaper at our scale than having guys running out replacing disks and motherboards. Again, they're not necessarily work in an enterprise data center, but it's an interesting story, again, where I'm trying to get across this one-size-fits-all architecture may not necessarily be appropriate. You've got to look at the services that you're providing and the scale that you're at to where that economic sweet spot is of where these things are cheapest to run. So let's have a look at some of the challenges of providing a dynamic data center. So as I've said, high levels of automation and orchestration are key, and I am making this distinction between automation and orchestration. So, and I'll get into that in a little bit more detail later on. Process and standardization are king, and I can't stress this enough. You need the processes at the back end. Now, the technology can help facilitate those processes, but you need good processes to begin with. So when we talk about private cloud implementations and when we do this with customers, we spend a lot of time looking at their processes and where we can streamline them and where we can optimize them, because automating a bad process is still a bad process. And with these systems, efficiency is absolutely king. You want to be squeezing as much out of these shared resource pools as you can possibly get. So having consistency and really efficient processes is just so important. Now, the next challenges that I'm going to call out are really more organizational. Now, just a quick show of hands, who works in an organization where your IT teams are siloed into discrete areas of responsibility? So you've got your storage guys, your network guys, your server guys, etc. Who works in an environment like that? Wow, that's a lot less hands than I was expecting. Certainly when most organizations get to a certain scale, that's the natural way of, you need to divide things up. So that's the natural way things work. Now, out of those hands, okay, I should have said who has worked, because I probably would have got more hands. So I'll change it. Who has worked in an organization where they have siloed teams, and those siloed teams don't necessarily get on as well as they should? There's maybe the odd turf war, there's a bit of us versus them, yep, okay. There is no bigger enemy to private cloud than that. As I stated before, you need automation and orchestration across those silos. Now, when we start to look at organizations and start to introduce these systems, that really does represent some challenges, because you really start to get into what I like to call the mortgage factor. People start to feel that they feel threatened. If you've got a storage guy, for example, who sits there, who earns pretty okay living, just provisioning LUNs all day and doing your basic maintenance stuff, gets requests and services a request and a little bit of a tick and flick sort of thing. When you talk about automating that process and taking that job away, then people start getting really, hot under the collar about that kind of thing. So ultimately, I think the advice I'd give you in terms of best practices, it depends on which angle you're coming from when you're talking about private cloud. If you're coming from a management, executive, business decision maker viewpoint, you've got to be aware that if you are going to want to introduce this type of system, you could meet some substantial resistance from the actual IT teams in terms of delivery. And we've certainly seen in the past, areas white-handing each other left, right, and centre to try and, they don't like what's going on. So, people will quite often act on their own when they see something they don't like. So you need to be aware that that's a challenge that you could face. And I would advise to really spend some time up front reassuring those individuals, saying, look, no, your job's not going to go away, just what you do is going to change a little bit. And really get all those teams on the same page with what you're trying to deliver to your customers, because if they're all on the same page, it's going to make it infinitely easier and you're not going to have people fighting the process. You're coming from an IT pro, sysadmin type of angle, and you're looking at private cloud going, I can really see the benefits, I can really see the agile delivery for our customers, and I can see all the benefits that it's going to bring to us. Don't just try and get the system in on your own. You need management support, you need executive buy-in, because when or if the resistance comes from those other teams, you need someone who can back you up and come in with either a carrot or a stick or a combination of both to break down those walls and get through that. And as technologists, sometimes we get a little bit when we start talking about organisational stuff and politics, but these things really are real blocks, and definitely they're the largest challenges we face. The technology comparatively is easy compared to some of those organisational challenges. So now, now that I've just blinded you with white, I thought I'd change it up from the purple. I want to talk to you about the infrastructure as a service system that has been built by Microsoft Services. Now, this is going to start getting a little bit. I'm going to throw out a challenge to everyone. See how much you're paying attention. What I am showing you here is not a product. It's called DCS, or Data Center Services. It is a solution offering which has been developed by Microsoft Services. This is not a Microsoft product. Now, the challenge is at the end of the session, I'm going to ask everyone, how many times did I say DCS is not a product? In fact, in the DCS architecture team, that's a drinking game. Every time you say DCS is not a product, DCS is not a product. This is a solution offering. Now, the reason why I'm showing it to you is twofold. Number one, quick plug, and this is the only one that I will do, is that this is a service that is available from Microsoft Services. You can contact MCS and we can roll in and start talking to you about how potentially we could implement this in your organisation. My only plug. For everybody else, this is a great example of an infrastructure as a service private cloud system that is built on our stack. Absolutely no reason why you guys can't go out and do the same thing. What I will also say is this is not futures, right? I'm not a marketing guy, I'm not a sales guy. I care about what technology, I love the future stuff and it's cool, but I really care about what our technology can do right now today. So everything that I'm showing you is in the marketplace today. You can go and build it today on all the existing release of the product set. You don't have to wait for any of this to make this a reality. This is all on today's tech. So, when we built our infrastructure as a service system, or our solution, DCS is not a product, what we really looked at was these underlying foundational services. So you've obviously got your physical tenants there, compute, network, facility, etc., hardware layer, and then a virtualization layer. Now, you might notice there's a lot of white space above virtualization, right? Virtualization is by no means the end of this. It's just the start. We then have our automation, management, orchestration, and interfaces. So when we talk about an automation layer, we're talking about things like PowerShell, WMI, and access to our products via all the available and published APIs. Our management layer is System Center, our System Center suite. So you can see our product, this solution is quite comprehensive. It touches, depending on how much of it you want to implement, can potentially touch every product in the System Center suite. But there are a couple of elements to it which are absolutely critical, and I'll call that out as the real secret sauce of our solution. And I don't know if it'll surprise some of you to learn that that secret sauce is not really at the virtualization stack. We have our orchestration layer, which is serviced in our solution by System Center, a Palace integration server, because it's current tech. And then we have our interfaces on top, which is one interface for our self-service and then one interface for our admins. So these are some of the building blocks of our infrastructure as a service system. Now, when we built this system, DCS is not a product, it's a solution. When we built this, we really took a lot of learnings from how we manage our cloud services in our large data centers. So any of you who are familiar with the Windows Azure architecture will see some similarities here. And taken some learnings from that about how you manage a multi-tenant system, which you need to patch and maintain and keep up to date underneath, but you don't want to interrupt the service which is being supplied on the top. So we've got scale units, resource pools, fault domains, and upgrade domains. Now, I hate that we've used the term in there because it confuses people. I am not talking about an Active Directory domain. It's a logical region. In fact, I think we probably should have called them regions rather than domains. So, yeah, understand then I'm not talking about AD domains there. So let's have a look at how those things work, and I'll speak to each of them a little bit. So again, you can see my awesome diagram there. I'm obviously not getting a job in marketing anytime soon. So we've got our physical servers underneath that form our fabric. We've got our hypervisor layer. We've got services on top, and our management system and the health status of the system. So a resource pool is just a logical collection within your data center, and it's going to be a little bit different for each organization what constitutes a resource pool. The most common the common barrier that we see for resource pools, and where it makes sense for most customers, is that level of service, the bronze, silver, gold, whatever you want to call it. So we find that, one cluster or a number of clusters going to low-end storage, which is the bronze, that's a resource pool. The one going to the super high-fast stuff for high performance and production, that's a resource pool. So that's one reason to carve up that's one way you can carve up your resource pools. Then we have the notion of what we call a scale unit. Now, a scale unit within the DCS solution, DCS is not a product, is out of box is a 16-node Hyper-V cluster. That's pretty big. Again, this solution was developed in the US, so we had sort of larger scale in mind. So yeah, 16-node cluster. For a lot of organizations in Australia, that's probably a little sizey. So you may make it a 4 or an 8-node cluster or something along those lines. But the concept is that you define a very strict set of standards around what constitutes a scale unit. And you need to know to a very good level of detail how much a scale unit costs and how long it's going to take you to deploy a scale unit. And that includes purchasing of the servers, how long that procurement process takes, how long it takes them to arrive, and how long it takes them to get them racked and cabled and into your data center. We have the joke in the DCS team, it's a fairly feeble one, but anyway, until robotics starts getting a lot more affordable, true zero touch is just not possible. You still need a human to go in and physically rack and cable the gear up, right? So, and even though we get into this mindset of virtualization, yeah, we can provision a server within, whatever, ultimately that has to run on tin at the end of the day. So those scale units are the, capacity of tin that you need to keep making that service a reality. You then monitor your service and look at the consumption rate that you're experiencing. And when you get to X% of consumption, that triggers the implementation of another scale unit. And that's how we do things in our data centers. Agreeably, our scale unit is a container with 2,000 servers in it, but you get the idea. The scale of that scale unit is going to vary depending on the size of your organization and your needs. It's all about the predictability of how quickly you can deploy that scale unit. A fault domain. Again, this is the resiliency over redundancy mindset. This is in data centers, we're trying to get out of this thing of trying to eliminate all single points of failure because it's just too damned expensive. So what we want to do is acknowledge where those single points of failure are, and that's what we call fault domain. So again, the definition may vary slightly depending on your organization. Some of our customers define a data center as a fault domain if that entire data center goes down, for some of our larger customers who have multiple data centers. In most cases, we find a good common sense place for a fault domain as a cluster, because quite often that cluster will be attached to a SAN. That SAN is a single point of failure. So if the SAN goes down, the whole cluster is going to go down, right? So that cluster is a fault domain. The idea is to architect the services and the applications running on that infrastructure so that it can survive the loss of a fault domain. In case those failures, which do occur, we all know they occur. I mean, hands up who's ever been in this situation where they've been in an organization where you've paid an absolute fortune for, say, I don't know, a SAN, which is supposed to have redundancy up to wazoo and back, and has still suffered a critical failure and the whole thing's gone down. A lot of hands, yeah. So we're moving out of that mindset of trying to throw money at this problem, trying to make it more and more redundant, to say, well, you know what, we are going to acknowledge that we know these failures happen, and if they do, we want to make sure our service is resilient to that. Now again, this comes back to quality of service and cost. So for some customers, they may not want to have their architecture spread across so much infrastructure that it can survive the loss of a data center. That might be too expensive for them. So that's when you start looking at, okay, well, this is your bronze service then. If this particular fault domain goes down, you may well lose service for a while. That's not really, that's kind of going against the whole tenet of cloud a little bit, but we do have to be realistic about how these things are going to operate at lower scales when, not all of us have unlimited budgets. Upgrade domain, and I'll actually park this one because I'm going to go into a lot more detail about how that works, but the concept is basically that you have I'll go through it. I'll illustrate it with some really cool animations, so that'll make it clear. And resource decay is something that I talked about before, and I'll park that one and go on in a little bit more detail about how we see that working at the lower scale of an enterprise data center where you may not have the luxury of letting things rot in a rack forever once they've died. So now I'm going to take you through the actual architecture for DCS, which is again the Microsoft Services solution. DCS is not a product. Sometimes it walks like a product and it quacks like a product, but DCS is not a product. We've just released version 1.1 of DCS, which is not a product. What that offers out of the box is automated scale unit deployment. So in our case, out of the box, that's a 16-node Hyper-V cluster. With our automation system, once the required hardware for the scale unit is racked and cabled, we can deploy a scale unit end-to-end, almost zero touch in 1 hour. And I say almost zero touch because there is a manual intervention step in there, which is important, but that speaks really well to how you integrate it with your processes, and I'll go into that in a minute. We have a self-service interface and also an admin interface. Automated patching, fault detection and resolution. We have built-in multi-tenancy and true multi-tenancy, so users can't see other users' stuff, which is always nice. People talk about the Coke and Pepsi analogy. If one of your customers is Coke and another one's Pepsi, you may not necessarily wanting them seeing each other's stuff. And the big thing for me with this system is because we've built it on the framework of the System Center Suite, DCS is not a product, it's extensible. You can change bits and pieces and integrate it into other systems, and it's not out of the box sort of shrink wrapped product. Then you go, yeah, it's good, but it meets about 80% of what I want, and if you're getting 80% of what you want with an out of box product, yeah, it's pretty good. It's extensible. We've done a lot of the heavy lifting and a lot of the pre-automation, and a lot of that work's done for you, but it's certainly, the system is then extensible and customizable as well. So the architecture of DCS. Now I'm going to call out a couple of things here which I think are the secret sauce to how DCS is a good, sustainable infrastructure as a service private cloud. Firstly, we have System Center Service Manager. Now that's really the brain of DCS because it gives us a couple of features which I think are absolutely necessary for successful private cloud. Number one, it gives us a CMDB, both for all of the fabric components and also all of the VMs which are being created by tenants. It also, and this is the critical part for me, is wraps everything up that DCS does into good, solid, repeatable ITIL process. A couple of the architects who worked on the DCS solution, DCS is not a product, are certified ITIL masters. So they were very keen to make sure that everything that we were doing was really wrapped up into solid ITIL process. When a customer goes to the portal to request a VM, that automatically raises a change request in Service Manager. Now, for most organizations, we'd really recommend that approval of that change request is automatic. So it's an auto approval, so you've got that rapid deployment and you've got that agility. But for some organizations, they might say, well, we want a human being to approve that request before it goes any further. And that's the great thing about the extensibility by leveraging Service Manager, is if you want to put a Service Manager workflow in there that says when someone requests something, actually shoot a request off to this individual who has to approve it, then all you have to do is approve, make the approval in Service Manager, and then the automation kicks off again from there. So those processes are customizable depending on what works for your organization. Now, the other part of the architecture that I'll call out again, which is secret sauce, is a Parlous integration server. Very important to have end-to-end orchestration of these processes so that you can cross these discrete silos. And this is what Parlous integration server gives us, is the ability to do that. So I'll quickly go through some of these slides. I'm starting to get into the time where I really want to start talking about the demo. So let's have a quick look at the infrastructure relationship. So we've got our infrastructure as a service fabric, which is the entirety of the system. Within that, you have a data center / site, and you may have multiples of these. Within that, you have a resource pool. Again, a sensible way of carving that up is in terms of quality of service, but you can carve it up however you like. Within resource pools, you will have any number, potentially, of clusters servicing that resource pool. So there you can see hosts. Now, that little blue bar down the side, let's come up all right, that's our notion of an upgrade domain. Now, so what we do is when we do our upgrades, we classify boxes within an upgrade domain, and I've got an animation that shows how that works. And then, of course, wash, rinse, repeat, scale out as required. So, tenant and service management. DCS out of the box. DCS is not a product. Each tenant, it's a true multi-tenant system. So we can have any number of tenants within the system who don't have access to each other's stuff. Within a tenant, you then create what we call services. And all a service is a logical grouping of virtual machines. So again, a service may mean different things to different organizations. So one organization might define as a one tenant, shall we say, because a tenant could be multiple business units within the one organization, depending on what you're doing. A service could be SharePoint. The guys who look after SharePoint, that's the SharePoint service, and that's their little slice of the pie. For another organization, they might say, okay, well, discrete business units are a service. So it's really just a logical separation. You carve it up how you want. The critical part is that within the system, we supply each tenant a quota of how much of the fabric they're allowed to consume. Now, that tenant can subdivide that quota to their services. So when you're thinking about, okay, well, how do I define a service within my organization? It's really about, well, the service is something where I want a discrete quota assigned to it. So I might want to give the SharePoint guys more quota than I give the Exchange guys or whatever it is. Now, within that service, then the consumer is free to provision and deprovision as they like. Now, this is part of how we try and incent people to have the right behavior in terms of that perception of infinite capacity. If you give a business unit a quota and say, okay, here's your quota, fill your boots, but you're not going to increase that quota, that's how you incent them to maybe not have really old VMs that they've had for 6 months that they don't no longer need, have hanging around in the system. They manage their own quota. So, if they've really got a good legitimate business reason as to why they need more, you might grant them more, but in most cases you'd say, well, that's the quota you've got. You need to manage, what you're going to be running within that quota. I was speaking to some people at a networking event last night, and they were saying, can this system automatically shut servers off when, if I say I need it for 2 weeks, can it shut it down? And I said, well, no, out of the box it doesn't do it. You could, of course, through the orchestrator automation, you could certainly put that in. I'd call it the Nazi workflow, if you like. Say, right, when was this thing created? How long should it be in service? Oh, it's past its date. Shut them down. If you want to be that hardcore about it. But I'd say it's more about if you give them a quota that they have to manage themselves, then it's going to be a lot, that's going to try and push them towards the right behaviours of not encouraging VM sprawl. Virtual machine provisioning. Again, within the DCS system, this is what I'm talking. DCS is not a product. The administrator chooses a VM template. I won't talk to this too much because I'll show you it in the demo if it works. And they choose the size of their VM. Now, one thing you will notice, and we really want to talk about a service provider's mindset So when you're providing private cloud within your organization, one of the things, the mindset you've absolutely critically got to have is a service provider's mindset. If you're providing the service internally to your own organization, it's very easy to think of them as users instead of customers. If you're talking private cloud, you've always got to be asking yourself the question, is this level of service, would this level of service be acceptable if they were paying for it? And if the answer is no, then you've got to do a better job. It's a service provider's mindset. Now, so we've done that with DCS in terms of when people provision a virtual machine, it's very much like a shopping cart experience, what you get, when you go to a car website and you go, I want this car, but I want leather seats and I want ABS and I want these options, then you can see the price ticking up as you check the options. And that's exactly what we've done with the portal, is provide that sort of shopping cart experience. Yes, I want this resource pool, and that's this much a month, and I want this many extra disks, and that's this much extra. So people can see what the cost of that service is, and that also incentivizes that good behavior from a service consumer point of view, where if it's the organization's money, if you've just got, what size VM do you want, small, medium, large, whatever, people are going to go, well, I don't know what I need, extra large. People will always go err on the side of caution and go for bigger. So, but if you've got something over to the side that says, the extra large is this much, and they go, yeah, okay, maybe I only need the medium. That's this much. Yeah. Okay. So you want to, again, push your consumers towards the right behaviour. Automatic provisioning, of course, of most of Windows OSs. One thing that we're very proud of in DCS 1.1, DCS is not a product, is that Linux is a first-class citizen. So we have zero-touch deployment of Linux OSs as well, and I can tell you that was not easy to achieve. They're not, in some ways, as friendly with the deployment technologies on Linux as they are on Windows. So we had to do some pretty tricky things to get that zero-touch of Linux distros happening. Reporting and capacity management, obviously very important. We achieved that through integration with System Center Operations Manager and also System Center Service Manager, and using the very powerful inbuilt systems of SQL reporting services from both of those products to generate really rich reporting. And that speaks to the chargeback as well. So you've got chargeback and you've got quota, which are two things you can use to incent the right behavior. SCAR unit provisioning, again, out of the box with DCS. DCS is not a product. We have a separate management cluster, which is our best practice. So depending on the scale of the organization, in most places it'll be a 2-node cluster. We'll set up a 2-node Hyper-V cluster, which is where all of our management servers live. So that's where Ops Manager and Config Manager and VMM and Apalis and all the other services, that's where they all live, and they're on their own separate cluster. So you want to separate the cluster of those from the clusters that don't actually provide the capability for the fabric. So once that management cluster is in, and within the DCS system, DCS is not a product, we have that fully hydrated. So that's totally automated deployment of that system. We can roll that management fabric in very quickly. Once that's in, we can then provision our SCAR units. Again, we can configure how big those SCAR units are, but it's a 16-node cluster by default. At the moment, the LUNs and VLANs have to be manually created, again, out of the box. But again, you've got Apalis within the system, so you do have that option to potentially automate the LUN and network creation depending on what scripting interfaces are available to you on those systems. So that can be automated as well, but it's not done out of the box with this release. The administrator enters all the information for the SCAR unit, so all the server names and MAC addresses, which is the bare information that we need. Once that's done, then the system again by default will deploy a 16-node Hyper-V on server core infrastructure. And again, to deploy a 16-node cluster on most hardware takes about an hour. We use multicast, so it deploys quite quickly to those 16 nodes, sets up all the CSV, sets up string. Now, when I mentioned it before, I said it was almost zero touch. And one of the critical pause states in there is once the cluster is built, the change record that's raised in Service Manager then goes into a state that's awaiting approval. What that's waiting for is the administrator to go into the cluster and run the cluster validator to make sure that they've got all green ticks. So anyone who's built a cluster on 2008 and has been through that experience knows the support story on 2003 was a bit of a nightmare. 2008, we run the cluster validator. If you get all green ticks, then you are supported. So we need a human being to go in and validate that cluster, make sure they've got all green ticks. They then approve the record in Service Manager, and then the rest of the automation kicks off. So that's a good example of where we can interject approval process within the automated system. Patching. This is the illustration of the upgrade domain that I was talking about. When you patch, you can patch pretty much any level you like, but we actually recommend patching a resource pool. It's one of the most efficient ways of doing it. So you simply say, right, patch resource pool A, resource pool bronze, or whatever you've called it. Patch the resource pool. The system will then go look and identify every cluster that's in that resource pool. It will then identify the first node that is in every cluster of that resource pool. It will put those first nodes into maintenance mode in Virtual Machine Manager, which will evacuate all the VMs via live migration onto the other hosts. It'll automatically pause the node in Cluster Manager so that you don't VMs failing over to it. It'll also pause it in Ops Manager so you don't start getting alerts when it reboots because of patching. It then patches the system, then does quite a sophisticated checking routine to make sure that all of those patches have been successfully applied, and if they had, then it has, and then it washes, rinses and repeats through the entire cluster. So if you've got, as in this case, 4 clusters in your resource pool, it's just going to wave through and patch all of those 4 clusters simultaneously. What it will also do is it does a lot of checking at every stage. If something's happened that the system doesn't like, so if the tester, say, did this patch successfully install, if that fails, then it'll automatically generate an incident report in Service Manager for the administrators to go and have a look at what happened. It will also take that resource then out of the resource pool because it knows there's something up with it. So that's that decay that we were talking about, puts it out of the system so it's not available for use. And it also then reports back that your capacity has been reduced by X amount. And that really goes towards this next slide, which is talking about a failure on a host. Again, it could be a critical hardware failure, or it could be a patching process that failed, or whatever it is. We'll put it into, make it not available to the system, and then reports back. Now, again, in most enterprises, you're not going to do what we do, which is just leave stuff, forever. At some point, you probably want to go out and replace stuff. So there's 2 ways really of doing that. You can say, we know what our capacity is, we know what our demand is. We wait until we get a failure rate of X%. Then we go out and send a guy out to change disks or change motherboards or do whatever it needs to be done. Or you can say we have scheduled maintenance that runs every 3 months or 6 months, or it depends on the size of the data center and your mean failure rate and that kind of thing. But the important thing is that the system knows when a system's failed and puts it out of play until such time as it needs to be going and investigated. And we're trying to get out of that mindset of going and running to a box every time, people have got kids. Sometimes it's not the best thing to go running to them immediately every time they cry, right? It's the same thing. We want to get out of this mindset of going and running to a box every time that, there's something a little bit wrong. If the service can survive is resilient enough to survive that failure. Okay, so now I'm going to attempt to show you the DCS system that I've built. Oh, that I've built, that MCS has built. DCS is not a product. Now, I didn't really have what I was going to show you scripted, a rough idea. I'll show you the tenant interface, show you a little bit of the multi-tenancy, I'll show you what the provision page looks like. But really, the whole system's there. So if you want to go and look at something specific, call out, let me know, and I'll show you, assuming it works. The other thing that I did want to spend a little bit of time showing you is the Service Manager interface and how it integrates with Service Manager, and also have a look at some of the Apalus stuff. Now, some of the Apalus workflows that we have are reasonably advanced. So, and they were actually, a lot of them were built out for us by guys from Apalus. So it really does represent the best practice of how you build efficient Apalus workflows. So if any of you guys are specifically interested in Apalus and how to do that, come up and see me afterwards, and I'll explain in as much nauseating detail as you can stay awake for the best practice of how to build some of those more complex workflows. Okay, so yeah, I'm remoted into a Hyper-V box in Redmond. Someone's already on that box. I'm going to kick them off because I did have the lab reserved. Okay, someone's been doing stuff by the look of it. Okay, so this is the Silverlight based interface that we wrote for the tenant. This is the tenant interface. So I mentioned before we had two interfaces, and yeah, whether you want one or two, some people sort of look and go, two interfaces, but interfaces is good from the point of view that you have a very clear distinction between your tenants and your administrators. And to really get one interface for both, there's really a lot of heavy lifting involved in trying to service or surface everything that the admins need in the UI, when you may not necessarily, when all of that stuff is surfaced through the native console of the product that's doing the work anyway. So why would you go to the expense of doing all that dev when the stuff's in the console natively? So the tenant interface is a custom written Silverlight web portal. The management or the administrator interface is the System Center Service Manager console. So you can see this is the home page. Now I'm currently logged on as a DCS administrator. So you can see up here, very sort of SharePointy type, tells you who you are. So that is showing you both the service administration actions there, and also you've got your tenant, tenant admin stuff there. So the interface is security context trimmed. So if you were a tenant, you obviously wouldn't see the tenant administration things. So if we go to just the overview, okay, someone's been doing some testing by the look at it. At the moment, we've got one tenant in the system. Now, what I've done previously is gone through and created a request for a new tenant. So if we have a look at that web portal, it's pretty basic, a tenant name and just an amount of quota that you want to assign to them. So if we actually jump over to, I've previously created one, which I hope will still be in the system. Actually, what I might do is that's not the user I was expecting to be logged on with, so I'll log on as another user. Yeah, that's more what I was expecting to see. Okay, so you can see if I pop over to the Service Manager box now and show you, I've pre-created the request for a new tenant. I'll show you how that actually then creates records in System Center Service Manager. So this is the System Center Service Manager interface. One of the things that DCS supplies, DCS is not a product, is a management pack for System Center Service Manager. So you'll see you've got your normal library work items, configuration items, but there's also this new wonder bar that we've added, Data Center Services, and this has all the information relevant to the DCS solution. So here, let me just zoom in. You can see these are all the configuration items that are relevant to the fabric. So you've got domain and networks and physical location, VLANs, your templates in terms of virtual machine provisioning, tenant services, and virtual machine. Now, if I go and have a look at my new tenant requests, you can see there that we've got a Contoso HR, that's better, Contoso HR request, which is one that I requested earlier. So if we have a look, you can see up the top there that its status is requested. So if I now go and change that to in service, which means that I'm now approving, this person as a tenant, it's disappeared from new tenant requests. It is now a configuration item as a true tenant. So if I go back to the interface, and I've got this minimized so Zoom it works, so excuse my scrolling around. If I now refresh that interface as an admin, it's subtle so you may not notice, but that little Silverlight animation down the bottom there, that one, there was only one tenant in the system before, so I was seeing the service, all the services for that tenant. Now I've got multiple tenants. I'm seeing a graphical representation of their resource usage in terms of that actual, the multiple tenants that I have on the system. You can see in terms of blue and green is the amount of allocated and available quota for those relative tenants, and also the number of virtual machines that they have in play. So if I go and have a look at the tenant overview, and if you're a tenant, this is the interface that you would see. We've got Contoso HR, which actually hasn't had any services or VMs provisioned within a service. If I look at the other tenant, you can see we have 2 services, and again, these are just logical groupings with separate quotas applied, and how many virtual machines they actually have. So I can actually go in and have a look at the virtual machines in a little bit more detail, which is no, sorry. Yes, because I have no. Yes, thank you. I have no tenancy. Someone switched on. Okay, so I can then go in and effectively manage that so I can assign various quotas, or I can add additional services. So if we have a look at our virtual machine overview, and again, we're not going to see anything for HR. And again, the interface is security context trimmed, so if I only had access to the one service, I'm not going to see the others in the pull-down list. Because I'm a DCS administrator, I can see everything. Here we have the overview of our virtual machines, and you can see here that I've got 2 VMs on the side here, and I've got some basic health information. I've got a green icon for system status and also for performance. Now, it's drilling into System Center Operations Manager to get some of that performance information. I've also got bars which for backup and update. It will, in our lab at the moment, we don't have it configured, which is why those bars aren't coloured. But in a configured environment, that would be reaching into Data Protection Manager for the backup status. I'm reaching into Config Manager for the update status, and then giving us a quick dashboard on what the status of that VM is. You can see here on the side, we've got some basic performance information that's been gained for that VM. In this actual instance, that particular bit in the console, it's actually getting that from the Hyper-V host itself. It's using the performance counters on Hyper-V to obtain that information. Don't forget about Performance Monitor if you're using Hyper-V. I see a lot of criticism out there saying, oh yeah, but Hyper-V, there's no monitoring if you don't have Ops Manager, and I know Performance Monitor isn't the sexiest looking tool in the world, but every Windows admin worth a pinch of salt should know how to use Performance Monitor, and there are about a million counters for Hyper-V that can monitor the system to the nth degree. So don't forget about Performance Monitor. So that's where that's gaining some of that basic information from. As you can see, I've got my basic functions of being able to start, stop, shut down, pause, etc. I can look at the system alerts if there are any, in which case, in this case, there aren't. The system properties, now, well, that was a lot quicker than yesterday. Someone's been doing stuff. It's gaining that information mostly from the configuration items and System Center Service Manager. So this is the whole System Center suite really coming together to give you all of the information that you need. If I go into performance monitoring, it's a shame actually because that's a really slick Silverlight animation that just doesn't come across when you're IDPing back to the States, but trust me, when you're on the local console, it looks really cool. It's getting all of this performance information by drilling into Operations Manager. So I can, I can expand a particular counter and get more detail. and reduce. And obviously, you know, what you're seeing is what reports you see out of the box are fairly well customizable. So, having a look at again at System Center Service Manager, again, as I stated, everything is wrapped up in ITIL process. So, you know, we know about incident reports. We automatically raise incident reports when things go wrong or failures are detected. And again, it's using Operations Manager and the Monitoring and Operations Manager to achieve a lot of that. You can see here we've got VM provisioning. So when a provisioning request is made, again, change records raised in Service Manager so we can track that to a pretty high degree of detail. Again, so we've got obviously completed, failed, in progress, and submitted and paused. So again, that's potentially somewhere where you could look if there's some kind of manual approval process needed to get VM to the end state. Yep. Now, I wanted to quickly show you as well some of the Opalis workflows that we have back-ending the system. As you can see, we have, you know, quite a number of workflows. One area where we make pretty substantial investment in DCS is not a product, is in the area of error trapping and reporting. So all of our scripts in DCS have really thorough error handling and reporting, and also all of the workflows within Opalis have very thorough error handling and reporting. If an error is trapped in any of the Opalis workflows, it will actually then parse out to this error routine workflow, which then actually puts the status of the job into a failed state and then raises an incident in Service Manager. That incident in Service Manager will have a high degree of detail as to what stage of the process the error occurred and what the detail of the error was, which gets parsed out from either the scripts or the Opalis workflows. One thing I wanted to quickly touch on, because I've only got a few minutes, is looking at the VM provisioning process and point out just a couple of Opalis workflow best practices that we have in DCS. And this is taking a little while, that's okay. One of them is not to have really large workflows. Break your workflows up into multiple things. You can see here that we have, you know, not a hugely complex workflow. That one's only got about, you know, four stages in it, but we've got multiple workflows within this host patching routine, which we call at various times. The key with Opalis is to make your workflows as modular as you possibly can. That way, it's easy to replace components when you need to. One thing with DCS is we achieve a lot in DCS through integration with Service Manager and Opalis. A lot of that functionality will actually be taken over by Virtual Machine Manager natively when 2012 ships, because Virtual Machine Manager 2012 natively understands a lot of these things like clouds and, you know, resource pools and that kind of thing. So all those modular workflows that we have that do all that through customization that we have, because of that modularity, when 2012 ships, we're just going to go throw that bit of customization out and plug in the out-of-box feature. So that's how you keep these systems agile and keep them upgradable when new versions of the product ship, is to keep all of these pieces as modular as possible. Now I have 1 minute, so the other thing I wanted to show you, if it's going to work for me, here we go, is this notion of a provisioning engine within Opalis. So this looks like a bit of a nightmare, and quite frankly, that's about as complex as you ever want a Opalis workflow to get. What we've done is, instead of stepping through a linear state, we use what we call state management in Service Manager. So when the record is raised, that record will have a particular code, and that code is its state, so where it's up to. So what we do, instead of when we do a provisioning process, because provisioning processes can take a while, I'm actually working on a version of this with a customer that will provision bare metal services as well as VMs. So that particular customer, again, pragmatic, most stuff is virtualized, but all their Exchange is physical and all their SQL is physical, which, you know, at their scale makes good sense. So if I go into this portal and I say I want to provision an SQL box, it'll go out and bare metal provision it from SCCM and not touch the VM infrastructure at all. And it's doing that through management within the Apollos workflow. But the state management is critical. Instead of, because they take a while, I mean, a bare metal build of a box is going to take a half hour, 45 minutes or whatever. From a memory usage perspective on the Apollos box, you don't want a single workflow grinding away for that length of time because it's consuming memory and consuming resources. So what we've done is we have a automated trawl process that basically goes through Service Manager, says, let's have a look at all the records that are in an active state, and then I'll trigger them. And then depending on where it is, what the code is, it'll route it to the appropriate part in the workflow. So it's all about workflow routing there. Okay, so I'm out of time. Someone's walking up at the back saying 0 minutes. I could keep showing you what's in DCS all day, but I've run out of time. So thanks very much for your time and coming to the early morning session. I hope you found the session useful and got something out of it. And I'll be hanging around if anyone else wants to ask questions afterwards. So thanks for your time.